So let's say you are given a compound like C, then H, all of them having single bonds. So the question is, how are you going to name such a compound like this, and how will this compound be named correctly, and how sure do you know that this compound is correct? So today we'll be looking at the naming of organic compounds, specifically alkane. So since we know there are single bonds here, we can recall that alkanes have only single bond. So the first thing that we have to know is that we have to know basically a set of rules. So we have to first know the number of carbon atoms and the name that is assigned to it based on the IUPAC rules. So first of all, if you have one carbon, it's simply called meth. If you have two carbons, you call that earth. If you have three, that's going to be prop. If you have four, that's going to be bute. If you have five, that's pent. If you have six carbons, that's simply going to be hex. If you have seven, hept. 8 is oct. 9 is non. 10 is simply going to be dec. Do you get it? So these are basically the 10 names, but however there are more. We have icosane and all those things. So that's basically the number of carbon atoms assigned to organic compounds when it comes to naming of basic organic compounds like this. Then the next thing that you have to do is that having single bonds, it is an alkane. So that means that the root name is ane, A-N-E. If it was double bond, it's going to be in. But right now we are dealing with single bond. So in this carbon, we can see that in this compound we have two carbons over here, and we have hydrogen bonds at the rest of them. So this is simply going to be ethane. Okay, ethane. Why ethane? Because it has two carbons, which is earth when it comes to organic chemistry, and it also have only single bonds. So that's where it gets its root name as ane, because it is an alkane. So let's assume we are given a compound like this. So we have our H bonding everywhere. So now again we have to count our longest chain, okay, our longest chain of carbons. And in this compound, the only longest chain of carbon that we have is 1, 2, 3, right? So that's three carbon atoms that we have in this compound, and the rest have been substituted with hydrogen atoms. So 3 stands for prop, so this is simply going to be named as prop, and they are all single bonds, so that's propane. So basically this is the first step in naming organic compounds. So the first step is that you have to number the longest continuous carbon chain. And if I say that, that simply means that you are going to look for the chain of carbons that has the longest root, so that you'll be able to name those carbons. Please note that there are many ways of representing organic compounds. It can be represented in different ways. This particular way of naming this, or sorry, representing this organic compound is called the opened structure. The opened structure representation. So in this structure, you can see that they have opened the structures for you to see all the bonds that are actually occurring. Then we have the condensed form of naming. We are doing naming, but then there are many ways they can represent this compound so that we don't get ourselves confused anywhere. So basically, there's another way of naming it. We have the condensed structure. Note that we'll go back to the naming. This is also a vital information. Okay, so the condensed structure has to do with they packing in some of the atoms to make it look more simpler. And as we know, condensed simply means something that has been packed in such a compact way to make it more simple to read or something. So in this compound, how they represent the condensed structure is that they first take the carbon and the number of hydrogens linked to that carbon, and they represent that as one unit. Do you get it? So over here we have a carbon over here, and we have three hydrogens over here. So this is my one carbon, and it's containing three hydrogens, so that's CH3. So this is one unit. Then they move to the next carbon. This carbon too is having two hydrogens, so that's CH2. This is another unit. Then this carbon is also having three other carbons bonded to it. Then that's the last unit. So this is the condensed structure of this whole compound. And note that they are both the same compound. There is no difference and there is no variation in these two compounds. The only thing is that they have been represented in a different order, or you might see it in the form of CH3 with a bond CH2 CH3. So this is still a condensed way of representing the compound, but just as for this one, they have brought bonds over here. So this is a half condensed structure, and this is actually a complete condensed structure. So let's try for this compound ethane. Ethane, that's going to simply be CH2 bonding to CH2. Then the last way of representing organic compounds is the bond angle or the bond line format. And the bond line format is simply using bonds, something like this. So if you see something like this, the first thing I have to do is I have to count the corners. That's the number of carbons you have. So this molecule or this compound is called propane, but we'll do more of the bond line format as we progress. For the sake of we remembering it, let's just stick with this way of naming compounds for now. Okay, so this is how we basically name compounds. If let's say we want to draw nonane, okay, let's say we want to draw nonane, an alkane with how many carbons? None is 9. So simply we are just going to draw the longest continuous carbon chains, 9 actually. So 1 2 3 4 5 6 7 8 9, right? Then now remember that it is saturated from the previous videos, so all these places are going to be substituted with what? Our hydrogens beautifully. So hydrogen here, hydrogen, hydrogen, like that. So hydrogen, okay, so as complete as that. Okay, so the next thing is let's say you see the presence of a substituent. How is it going to affect the naming? So basically we know that substituents are atoms or group of atoms that could replace these hydrogens in this compound. We should just recall that there are some compounds that are capable of substituting any hydrogen in this compound, and they come in two groups. We have the inorganic substituents, and we have the organic substituents, right? So let's say um okay, so let's say that we have three continuous carbons, then we have hydrogen here, we have hydrogen here. Let's say we have a Br molecule over here, we have hydrogen here. Let me add one carbon here. Yes, spare me time to write the hydrogen. Okay, that's just by the way. So yes, now we have our full complete compound like this. So how are we going to name such a compound like this? So we could see that there is one particular section of this compound, that's the hydrogen, has been substituted by an inorganic compound. So this is typically bromine in the compound. So what we do is that we first have to assign the number of carbon, or sorry, we have to assign the position of the carbon atom that the bromine is found on, so that it will give us reference to how that is looking like. So what we do is that we simply count from the shortest route to the substituent, so that it's going to give um, our compound more stability. When I mean shortest route, I mean that if you are counting from the end, that's the longest continuous carbon chain, and the substituent, the bromine has to take the least position. So if you count from this side, this is going to be 1, 2, 3, 4, 5. Do you see that? So if I literally count from this side, the bromine is on the second carbon. And if I count from this side, 1, 2, 3, 4, the bromine is on the fourth carbon. So literally we are going to take the smallest position, which is the second carbon, so that the reason why we take the smallest or the least position or the substituent is to offer more stability to the compound, because if it is on a higher carbon, it's going to make the molecule less stable. So now that we know that our bromine is on the second carbon, we number that position. So that's going to be 2 bromo. In organic chemistry, the presence of inorganic substances like chlorine is not actually called chlorine again, it's simply called chloro. If you have fluorine, they are basically halogens. That's going to be fluoro. Bromine is going to be bromo. Iodine is going to be iodo, and a whole lot. Do you get it? So this is 2 bromo. Then now you count the longest continuous set of carbon chain. Over here we basically have 1, 2, 3, 4, 5. So this is going to be pentane. This is going to be pentane, as simple as that. So please note that this is the correct naming of the compound, but not 4-bromopentane. This is going to be make the compound less stable. Okay, so let's try another question. So let's say we are yes, before we try another question, another way of representing this in the condensed form is going to be so this is going to be CH3 bonding to CH2, bonding to CH2, bonding to CH2. Sorry, here there is a Br, so bonding to CH, then your Br, then bonding to your CH3. As simple as that. If you want to represent this in a bond angle form, I remember that one point is a carbon. So over here, this is 1, 2, 3, 4, 5. So this is simply going to be 1. This is your first carbon. 2, 3, 4, 5. Can you see that? 1, 2, 3, 4, 5. And now you can name your bromine from this side. So we are going to count it 1, 2, and the bromine is on the second carbon. So we could attach the bromine to this side. So they are all the same compound. They are all the same compound. 2-bromopentane. Okay, let's assume we are given C, 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 C. Then we have a fluorine and we have a bromine on the second carbon, and we have our beautiful hydrogen atoms flying over the that's just I'm just kidding. I mean bonded. Okay, so in this compound, remember that the first thing I have to do is to what? Name the continuous. So 1, 2, 3, 4. So 4 in organic chemistry is basically bute. So that's going to be bute, right? I mean bute, and we have single bonds, so that's going to be butane. So now we have to assign positions to our beautiful substituents, which are basically inorganic. So over here we could see that we have the presence of a fluorine and a bromine on the second carbon, because we are going to name it from the shortest root, that's 1 2 and not 1 2 3, right? So over here, the what to be thinking about is, should we write the bromine or the fluorine first? So there is this rule that tells us that if we have the presence of multiple substituents, basically multiple different substituents, we are going to name it alphabetically. Okay, so even though we have the presence of fluorine and bromine, we are not going to write the fluorine first before the bromine, but we are going to write the bromine first before the fluorine due to the alphabetical rule. So the bromine is found on the second carbon, so that's 2 bromo, and the fluorine too is also found on that very carbon, so that's 2 fluoro. So this is how we are going to name this compound. Another way of representing it is 1 2 3 4. So 1 like this, 1 2 3 4. So this is butane. Then you could attach your bromine and your fluorine here. You are done for this compound. Okay, so let's assume we are given a compound. For the sake of practice, let's say we have 1 2 3 4 5 6. Let me add one carbon over here, 7. Then let's say we have our bromine here, another bromine here, and a fluorine here. Let's make this one more, okay, let's leave the substance like this. So we have hydrogen, um, this hydrogen is really work to write, but for the sake of practice, let's use this format. Okay, so we have a compound like this. So now remember that we have to count the longest continuous chain. So 1 2 3 4 5 6 7. So this is simply hept, right? So this is hept. There is the presence of single bond in all of them, so that's heptane because it's an alkane. And now we are left with numbering the substituent groups. So we choose the shortest route to make our everything more simple. So the shortest route is 1 2 3. Do you get it? 1 2 3. So here we have 2 bromine found on the second carbon, and we have 3 fluorine. A fluorine found on the third carbon. So in this case, how are we going to name it if we have one substituent appearing more than once? So the rule that is assigned to this is that if you see a substituent that is appearing more than once, then we name it di if it is 2, and try if it is 3. Let me write that over here. Let me pin that. So let's create this small section over here. So if it is 2 bromines, that's simply going to be di, right? Or if it's 2 substituents, if it's 3, that's tri, 4 tetra, 5 penta, 6 will be hexa, and going and like that. So basically you can see that this compound, the bromine is appearing twice on the second carbon. So what you do is that that's going to be 2 2 die because not because they are dead per se, but you could see 2 carbons, 2 substituents of the same manner. So that's 2 2 die. Then our bromo, dibromo. Then now we could name the other ones. Fluorine is on the third one, so 3 fluoro. Then our heptane. Note the use, how we use the dash and the comma. The dash is used in between a number and a letter, while the comma is used in between two numbers. Do you get it? Okay, so this can be also represented as, this is heptane, right? 1 2 3 4 5 6 7. So 1 2 3 4 5 6 7. Then we have bromine over here. You could represent it like this. This is your bromine, and this is your other bromine. Do you get it? Then we have fluorine here. You could either send it this way or that way. What matters is it's on the third carbon, unless it is alkenes that we'll be doing later, which we'll get to know cis and trans alkenes. So this is one way you can represent it in a skeletal form, or 2 3 4 5 6 7. You could also represent it like this. One bromine is here and one bromine is down here like that. Then you could represent your fluorine upwards. What matters is the position of where the substituent is located on. Then now let's say we have carbon, 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 carbon. Then let's say we have CH3 over here. Then we have our hydrogen here. Then let's put a bromine over here, or let's say a hydrogen over here, for the sake of practice. Okay, so once again, the same old rules that we are going to apply. So what's the first thing that we are going to do? So the first thing that we are going to do is that we are going to name what? The longest continuous carbon chain. So 1 2 3 4. That's one possible way of naming it. And 1 2 3 4. But they are all having the same number. So we could just take the longest straighter one. So that's 1 2 3 4, right? And 4 is simply bute. They all have single bonds. So that's butane. Butane. So now, what the next thing that you have to do is that there's the presence of a substituent over here. Yes, and I know if you are watching this or are doing organic for the first time, you'll be a little amazed and thrilled out. How come this CH3 is also a substituent? I thought it's only bromine and fluorine. Yes, we have substituents like this, but these substituents are made up of carbon and hydrogen, and they are called alkyl groups. In some situations, they are called alkyl, simply meaning that they are alkane groups that have lost one hydrogen to form a bond. Do you get it? So let's say we're having CH4. If CH4 loses one hydrogen to form a bond to this compound, CH4 is basically methane, right? Methane. So this is going to be methyl or methyl. Do you get it? So if we have, let's say, ethane, which was C2H6, when it loses one hydrogen to form a bond, that's going to be named ethyl, which is C2H5. Do you get it? Please, we should recall before we continue that the formula for alkane is CnH2n plus what? 2. Do you get it? So if we want the name for an alkane that has only one carbon, that's simply going to be C1H2 1 plus 2. H2 plus 2 is what? 4. So this is methane. But methane losing one hydrogen to form a bond or act as a substituent is going to be methyl. So in this situation, we have methyl on the second carbon. So this is simply going to be 2-methyl butane. So this is what we'll be covering in this video. But in other videos, we're going to solve more practice questions on the naming of alkanes.